Welcome to Renaissance Timing University. My name is Meng Lim. In this video, we're going to discuss about duty cycle on high-speed single-end clock buffer. For simple clock buffer, the output duty cycles highly depend on the input duty cycle. If the input duty cycle is 50%, the output duty cycle should be about 50%. But we have customer report that they have perfectly 50% duty cycle input, but they only get 20% or 30% duty cycle. So to explain that, we start from the very basic of the buffer input. Every buffer, single-ended buffer input, have a threshold voltage. With this threshold voltage, it's normally about half of the power supply voltage. So if the input voltage higher than this threshold voltage, then the output will be logic high. If the input voltage is lower than this below this threshold voltage, the output will be logic low. So for a normal signal, full swing normal CMOS input, if that's 50% duty cycle, it passed through this threshold at 50% duty cycle. So the output will have 50% duty cycle. Okay? But we have customer, sometimes they use a 2.5 volt CMOS to drive 3.3 volt buffer. So the 2.5 volt CMOS output is 0 volt to 2.5 volt. So it's a lot lower, and due to the rise and fall time, so the portion that passed through this threshold is containing less logic 1 time. The timing of logic 1 is much less. So it reflects to the output. Logic high is much less timing. So it's a less duty cycle that we reduce. So to solve this problem, we can find a way to shift this signal offset level up. So the midpoint will be go through the threshold voltage. So you correct those duty cycle to 50%. There's other factor of error on the duty cycle is this threshold voltage level can vary a little bit due to temperature process variation and also the power supply variation. So that can cause this threshold level move up and down and introduce some error on the duty cycle. So even you have 50%, perfectly 50% input, you might get only 48% or 52% duty cycle. So that's going to explain why the duty cycle gets some error. Thank you for watching this video.